Okay, ladies and gentlemen, welcome to the second video for section 2 of chapter 2, entitled Logic. Here we're going to be discussing a visual representation of what we've been talking about of compound statements, called the Venn diagram, that everyone should be familiar with, hopefully from a biology class, may have seen it in middle school math. But essentially here's how it works. The Venn diagram is a visual representation of whatever compound statement we're talking about. Each of our pieces, okay, so whether we're talking about P and Q or P or Q, remember P and Q are short for full statements, okay? We can represent the entire situation with this Venn diagram. Now what a Venn diagram is representing is everything. Every possible outcome there is shown in this two-circle Venn diagram, okay? That Venn diagram is representative of the situation, and it's broken into four pieces. We're going to label them A, B, C, and D. Okay. So if we wanted to see all the people, let's say we had something along the lines of like a student takes math, a student takes English as our two statements, P and Q. So all the students that take math would be in the math circle. All the students who take English would be in the English circle. Now notice that those two circles overlap. So when we're writing out our statements like P and Q, right? We could represent that using section B only, okay? P and Q would be only where those two circles intersect, only this middle area, okay? That would be P and Q. Okay? We could just as easily represent P or Q but that would involve more sections because, remember, it could be either or both or just, bits and pieces. So that would be sections A, B, and C combined. So if we drew that visually, we'd have our two circles, P and Q. P or Q would be all of P and Q combined. P or Q, okay, would be that entire area, both circles combined, including the intersection, okay? We could represent something like not P. Okay, in that case, we would be talking about sections C and D. So if we wanted not P, we would color in everything that was not in circle P. So all of this area outside of that would be considered not P. Things like that. Okay, and generally speaking, these are going to be not necessarily a coloring problem, but there will actually be numbers where A, B, C, and D are in the picture, and we'll be asked questions about our Venn diagram. Okay, I mean, we could literally do anything we wanted to do here. We could do not P and Q. We could do P and not Q. We could do, P or not Q. We could do not P or not Q. Whatever we needed, we could represent by adding up the numbers in those four areas, okay? So let's take it down to the next page and let's do an example. So here's a Venn diagram showing the number of people who can or cannot attend Spanish Club meetings in May and Spanish Club meetings in June. So the circle on the left represents the people who are able to go to the meeting in May. The circle on the right represents the people who are capable of going to the meeting in June. So the first question says, how many people are able to attend the meetings, the May or June meetings? So when we see the word or, that means we are looking at these three areas combined, because those are the people who are capable to go to a meeting either in June or in May. And yes, there are some folks that are going to be able to do both, but there are 5 people that can go in May, but not June. There are 6 people that can go in May and June. And there are 14 people who can go in June, but not in May. So that means there are a total of 25 people that can go in both May and June. Okay? So again, or is a combination of both areas combined. That's or. Okay? All right, the next one we're going to look at here is May and June meetings. How many people can attend both the May and June meetings? That would only be where those 2 areas intersect. That would be 6 people total are capable of going to both the May meeting and the June meeting. So then the other type of question that I could ask here is I could ask, what does that 14 represent? Well, the 14, okay, when I say the 14, I'm referring to this 14 right here. That 14 represents that there are 14 people who can attend the June meeting but not the May meetings. Okay, that 14 is representative of the people, the kids, the Spanish club members who are able to go to the June meeting, but they can't go to the May meeting. Notice how we're in the June circle, but we're not in the May circle. So that's an example of a 2-circle Venn diagram problem. Okay, the types of problems that we could see. Let's do another one. This one's going to be more complicated because instead of only having 2 sets, we're going to take it up to 3 sets. So here's a Venn diagram showing the number of students that are enrolled in tap, jazz, and ballet classes. Okay. Now notice that when 3 circles intersect, there's a lot more things that we could ask. Don't freak out. You can handle this. You just have to think graphically. Okay. So the first question says, okay, first of all, we got 3 circles here. We got tap, which is here. All those kids take tap. We've got jazz, which is these kids here. These kids take jazz dancing. And we have ballet. This many kids take ballet. Okay. So our first question says, how many students are enrolled in tap and is the key word, jazz. Remember that tap and jazz would only be the people that are in both circles. That would be that area right there, which would be 13 plus 9, or 22 students. Okay, next up we have tap or ballet. And again, the key word there is or. If it's tap or ballet, that can be either circle. Okay, so it'd be all of this area here would fit that description. So we'd have to add up all of those numbers. 28 plus 13 plus 17 plus 9 plus 25 plus 29. We'd add up all of those numbers together and we would come up with 121 students. Okay, 121 students are enrolled in either tap or ballet. Finally, we have how many students are not enrolled in tap. So if we wanted not enrolled in tap, that would be every student that is not in the tap circle. Okay? Every student that is not in the tap circle. Okay? That would be all of these people that are not within that tap circle. Those are the ones we would be adding up. So when we're adding those up, that is 29 plus 25 plus 43. And on occasion, there may even be some students listed that are not in any of them. In this case, there are none, so there's a 0 out there. And we add up those three numbers, that would be 97 students. There are 97 students that are not enrolled in a TAP class. Okay, so there's our Venn diagram examples. Thank you for your time.